Mixtures and Solutions, Part 4, Solubility. This video will explain how to predict the effect of temperature and pressure on the solubility of solid solutes and gaseous solutes. Solubility is a term used to describe how much solute can dissolve in a specific amount of solvent or solution. It can be expressed in concentration units. These three terms describe a solution relative to its solubility. An unsaturated solution contains less dissolved solute at a given temperature and pressure than can normally be dissolved, so it is less than its solubility. A saturated solution contains the maximum amount of solute for a given amount of solvent at a specific temperature and pressure, so it is at its solubility. A supersaturated solution is a special case. It's an unstable solution in which more than the normal maximum amount of solute is dissolved. It's past the solubility. The solubility of solid solutes increase with temperature, and it isn't really impacted by pressure. That means that for a solid solute, more of it can dissolve in the same amount of solvent at a higher temperature. How much more depends on the specific solid. A solubility curve shows the temperature dependence of solubility. This one clearly shows how generally solids are more and more soluble as temperature increases. For gaseous solutes, the opposite trend is observed. Gases tend to be less soluble with higher temperatures. This is because more of the gas particles at higher temperature will have sufficient kinetic energy to overcome the interparticle forces and escape into the gas phase. I'm sure you've observed that when your cold soda warms up to room temperature, it goes flat. It's flat because the CO2 that was dissolved has undissolved and escaped from the solution. The pressure above the surface of the liquid solution will also impact the solubility of gases in that solution. There's a directly proportional relationship between the pressure and the solubility of a gas. This relationship is known as Henry's law. This relationship exists because at higher pressure, escaping gas molecules are pushed back into the solution by the gas already above the solution's surface. You've probably noticed how the CO2 comes out of a soda when you've opened a pressurized bottle. The pressure is cut by a factor of about 4 when the bottle or can is opened, so the CO2 solubility drops proportionally and bubbles form and float out of the solution. So, to summarize, if you want to increase the solubility of a gas in a solution, like in your soda, you'll need to keep it closed so that it's at the high pressure it was bottled or canned under, and you need to keep it cold. Thanks for learning about the effect of temperature and pressure on the solubility of solid and gaseous solutes. See you next time.